Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have more than 14 years of work experience in the fields of artificial intelligence, software development, and robotics. In this session, I will create a project for transfer learning. I will give you again the brief about transfer learning, what it is. So the basic concept of machine learning is you will have some data with you, and what you will be doing with the data, it will be it will be a data set, and using that data set you will train a machine learning model. And the thing is, it requires a lot of data. For example, if you are training a image classification model or something like that, you will require 1 million or more than that images. So collecting all those images and running for hours for like 1 month, the training process is very time consuming. Okay, so you know the machine learning models typically require substantial data and time for training. So this requirement can be barrier in cases where data is scarce or training resources are limited. So you understand, on your computer you have limited resources. If you use Google Colab also, they will give you some limited resources to run your models. So after 1.5 hour or 2 hours, they will stop the instance, server instance. So you have limited training resources, but you have to train the model or create a model. So let's see this introduction. So what happens is, you already know, to train a machine learning model you will require a lot of data. So for example, you will require 1 million images to train a model for the image classification. So to collect that huge amount of data, and you already know that training resources are scarce. So on your computer you have limited resources, and if you run the training process on Google Colab also, they will only give the limited amount of compute power. So for example, after 1.5 hour they will stop your server, and you have to start the process again for training the model. So machine learning models typically require substantial data and time for training. Requirement can be barrier in cases where data is scarce or training resources are limited. Transfer learning offers a powerful solution by allowing us to leverage knowledge from a model trained. So you will use a base already trained model, and on top of that model you will create your own. So on a similar task and apply it to a new but related problem. This technique can save time, resources, and sometimes lead to more accurate models, especially in applications where high quality labeled data is hard to come by. So this is transfer learning. You will be having a base model, and on top of that base model you will be creating your own model. So it will take less time to train and run. So I have already created this project, so I will run this project and show you the time it takes to train. So python main.py. So you can see the time taken by the model to train. That's it. And test accuracy is 1 because I don't have much data to train it. So I will show you what kind of data I have. So in the train folder I have cats images. In dogs I have these dog images. So that's it. This is the data I have. And if I now test if the project is working, so let's see. I have set up this prediction server. So let's see. I'm just showing you, then I will tell you step by step how it is working. So this I am starting the server so that I can interface with this project. So this is the API, and let's see if I pass the image to it, what happens. So let's find out the files. So I have the dogs images, and I will use this image and when I click on send, it is saying prediction dogs. And if I give the image for cat, okay, so prediction cats, so it is just training for 10 seconds. It was able to detect cats and dogs. So the thing is, it was already trained on a huge amount of data, but it doesn't know about cat and dog. So for custom training data, you can give your own data, your own images, and this base model will help you out with transfer learning process. So I will show you this article that I created, Guide to Transfer Learning, and tell you step by step how this is working. Okay, so the base model I am using here is ResNet 18. So ResNet 18 is a pre-trained on the ImageNet dataset, which contains 1000 general classes. So what are classes? I told you. So I have images of dogs and cats. So there are two objects to detect or two animals to detect. So those are termed as classes in a technical term here. So we have 1000 general classes, like 1000 different objects were trained in the ResNet 18. So this is useful for recognizing those classes, but it doesn't help if you need to the model to classify images from different set of categories like cats, dogs, or specific product categories of e-commerce site. So it was trained on Tiger Airplane, like those kind of things, but it was not trained for cat, dog, or e-commerce website product categories for e-commerce website. So we can use this base model, and then on this base model we can on top create our own model. So this model that we create will be stored like this in models directory. We are using a base model now, so we don't have to train our machine learning model for hours. We can do it in minutes using transfer learning. Let's see. Transfer learning benefits leverages pre-trained knowledge. ResNet 18 initial layers have already learned to recognize general image features like edges, textures, shapes. Instead of training a model from scratch, which requires a lot of data and computing power, transfer learning allows us to use this feature recognition foundation and fine tune the model for a new specific task. So reduce training data requirements. Since the model already knows basic image features, training with a smaller custom dataset is often sufficient to make it accurate for the new task. So you don't need like 1 million images. You can use 50 or 100 images and train the machine learning model. Then comes the part custom images for specific needs. So by fine tuning on a set of custom images, we adapt ResNet 18's pre-trained knowledge to our specific classes. For example, if you want a classifier that distinguishes between cats and dogs, you will need to train the model on those specific images. ResNet 18 original 1000 classes won't cover custom classes unless fine-tuned. So this is what you need to do. Updating the model's final layer. So the final layer of ResNet 18 is specifically designed to output predictions for 1000 classes in the image net dataset. When using custom classes, we modify the last layer to output predictions. Remember this, we modify the last layer to output predictions to our specific categories like two classes, cat and dogs, or however many classes your dataset requires. And in this example I have used only two classes. You can add as many classes you want in the test and train folders. So name the you create a folder with the name of the class that you want to detect, and then keep all the images in that folder. This is the folder structure here. So we have two folders, train and test. In test, keep the testing images, and in train keep the training images. So this is how it works. Just remember, keep the name of the classes same in train and test. Keep the classes same. So load the ResNet 18, freeze early layers, Replace final layer. This is important. Fully connected layer with one that matches the number of classes in the custom dataset. Fine tune with custom images, custom classes. This is a cat and dog here are custom classes for us. So transfer learning is a powerful technique that leverages pre-trained models for specific tasks, reducing the need for large dataset and extensive computation. In this guide, we will walk through a complete workflow to implement transfer learning using pre-trained ResNet 18 model in PyTorch. Okay, so let's see prerequisites. This is what you need. First of all, a virtual environment. As you can see, I have created the VENV or virtual environment. So what's the command? It's very simple command. And this is the command to create virtual environment. Activate the virtual environment, upgrade the pip. Why to upgrade the pip? Because I am using Python version 3.9.6. Pip install requirement. This is something new for you. If you remember, I do pip install like numpy, matplotlib like this. So if the number of libraries are many and you want to install or manage the project easily, so what you can do is create new file with the name requirements.txt, and in each line write the name of the library you want to install. Okay, so create requirement.txt and write in each line name of the library. This is the first step. Next step is to run this command pip install -r requirements.txt, and this is same cached for storing all the temporary data while installing the library. So what this will do is install all the requirements from requirements.txt. So next time when you add new libraries, you can write like this each new library in next line, so it will install easily and you can easily manage your project using requirements.txt. And if you want to create requirement.txt automatically, so I have also included this command. So I will show you this. Requirements1.txt. Let's see what we have in this. So even the version numbers will be freezed here, and using the another command you can install all these library on your computer. So pip install -r requirement.txt cached it. This will install all the requirements, exact requirements on the other computer. So this command is very useful for you. This is pip install -r requirement.txt, and pip freeze this to create the requirement.txt. Okay, so let's see the next step. This is how you create the requirement.txt. So setting up the project and running the project. So step 1 for transfer learning, use custom data organized into train and test folder. I have already shown you these two folders with each category in a separate folder. So each category in a separate folder. In test I have each category in separate folder. Okay. Data transformations. To prepare images for the model, we will resize them to 224 by 224 pixels. Why? The required input size for ResNet 18. This is what ResNet 18 requires. So you have to resize your images in the same form. So you can see the images are in, each image is in different dimension. See, size for each image is different. If I go to details and see 832 by 555, 289 multiplied by 175. So you have to bring all the images in the same size. So resizing it to 24 by 224, and normalize the color channel to match the pre-trained ResNet model, and also the color channel should match the ResNet already trained model. Okay, so resizing it, converting it to tensor, normalizing it. This is what this code is. color channels, normalize the color channels. Okay, loading the data set process is simple. You give the data directory. So I have created with the name data. You can pass as per your requirement the name of the directory. Then we have image dataset, and image dataset are in the folder train and test. Train and test, and it will take all the data from all the two directories and store it in image underscore datasets dictionary here. And here we are just passing the argument batch size, shuffle, and other things, important things. That's it. Now comes the part of setting up the model. How you can include the ResNet model in your project. So this is the process. From models, Torch Vision, import models. There you will find ResNet 18, and this is pre-trained. You will get all the number of features using this, and this is the modification that has been done. So look at this: popular and modified fully connected layer to match number of classes in our dataset. And we will require loss function and optimizer to train the machine learning model. So what are these? These are just the settings you will require to train the machine learning model. And this is the part of training the model. And if you remember, I told you epoch. What epoch is? You will require at least 100 epoch to train something, train a model that is stable, at least stable. People train up to 300 epochs. So these are just the passes. The more passes it has, the more stable your model will be. So these are the number of epochs that it was showing earlier. If you see the output, these are the epochs. So it is printing from here. I will continue this session in next video. See you in next video. Have a nice day.